test documentation trying to figure out the output power level of this Hewlett-Packard 83712 Bravo 10 megahertz to 20 gigahertz synthesized CW generator. I have it hooked up with a 26.5 gigahertz Utiflex micro coax, so that is rated for the full range that this can do. And I have proper 3.5 millimeter, not SMA, male-to-male adapters, also rated up to 26.5. This is doing weird things for power output levels, but it does it in such a precise way that it makes me think there's some kind of setting that I just need to change instead of something broken. So we are at 100 megahertz. I have my marker there at 100. We're showing marker at like negative 90, and current output, let's see, yeah, we're turned on. So we're at negative 114, because it does have the option that goes down that far. And we can see the slight increase, but it says like negative 90. I have the reference at negative 40, so let's change that to, let's try negative 60. Yeah, it's basically noise floor. Let's go back to negative 40. Alright, so I'm going to go 10 dBm at the time, and there are occasionally power jumps at 10 marks. So right now, the Hewlett-Packard 8563 Echo spec analyzer is reading between negative 79 and negative 80 dBm, whereas this is at negative 101. I'll go to negative 100. You heard that click? Shit, I'll be right back. Sorry about that, I'm back. So we're at negative 100. We show like negative 78 to negative 79. Let's go transition. Oops, wrong way. There's the first jump. So at negative 91, we show negative 70. And when I transition to negative 90, it drops down to basically noise level, negative 86, 87. And then we'll go through the 80s, and we do see the spike come back up. So it is still outputting signal. And now at negative 81, we have like negative 79, negative 80. So let's go to negative 80. We still show around, well, negative 78, negative 79. So that's pretty close. Negative 71 gives us negative 70 point something. So 71 to 80 seems pretty accurate in terms of correct displayed power output to actual power output. I'm going to change the reference level now to negative 20 as we're going up. So we'll transition from negative 71 to 70. Big spike. So now at negative 70, we're at negative 50. And I'll keep scrolling down. We're at negative 61, negative 41. So the 70 to 61 range did have basically a constant 20 dBm difference. It's basically plus 20 dBm out, but otherwise it's like 61 equals 41, 70 equals 50. Let's go ahead, go to 60. We have a normal transition there. We're still off by exactly 20 dBm, so negative 60 there, negative 40 there. And we'll go through the 50s. So negative 51 is negative 31. When I go to negative 50, then we no longer have that 20 dBm differential, and now negative 50 equals negative 50. So this range, negative 50 to negative 41, there's negative 41, there's negative 41. Now I'm going to change the reference level to negative 10 as we're going up further. So let's go to negative 40. We have no surprises in that transition. Negative 40 there, negative 40 there. We'll go down to negative 31. Negative 31 there, negative 31 there. Not a surprise because all the relays and transitions are on the 10 marks. Let's go to negative 30. Big spike. Now we're at negative 10 dBm. So let's change the reference level to 0. So yeah, negative 30 here, negative 10 there. Let's actually change the reference to 10. There. So let's go to 21. Negative 21 here is negative 1.33 dBm there. Again, we're right at a pretty dead on or near dead on 20 dBm difference. Let's go to negative 20. Negative 20 here is negative 0.33. Let's go to 11. 11 here is 8.6, or sorry, negative 11 here is 8.67 dBm on the spec analyzer. And I'm going to increase the level to 20. No change in red power. Let's transition to negative 10 dBm. And now we had a power drop, and now negative 10 dBm here gives negative 11.17 dBm there. So very close. Not accurate, but, you know, sane, just not calibrated. We'll go to 1, or negative 1. And negative 1 dBm there shows as negative 2.17 dBm there. Let's transition to 0. That transition is smooth. We now have 0 dBm giving us negative 0.5. Let's go up to 10 or 9. 9 dBm there is 8.67. And I think there's no more transitions in terms of relays. 10 dBm, 9.67. Let's change the ceiling to 25. So 10 there, 9.5. I'll go up to 20 and no further. 20 dBm gives us 19 dBm there. And I'm not going to test further than that because my damage level here is 30 dBm and I don't want to get too close. Because, yeah, I got lucky to get this at auction. So yeah, that's what it's doing here. It really seems like I don't think it's damage because all of my power level segments that are incorrect by exact multiples of 10 dBm. So if anyone knows what's going on, I haven't found what I'm looking for yet in terms of something that could explain this, but yeah, this is what I'm seeing. Thank you.